Hello, my name is Alexis. I will be explaining my work for my thermal exam. Okay, so first we have our PV diagram for question 7. For our temperature, first temperature we have 290 K. Our U1 is 201.91. P1 is 1 bar. V1, this is pretty much all we know. P2 is 1830 kPa. U3 is equal to 1275.11 kilojoules per kilogram. U4 is equal to 588.74 kilojoules per kilogram. And then for a PV graph, this shows like process 1, 2, 3, and 4. For our first process, from process 1 to 2, we have to use this equation to find T2 and V2. We do T2 over 290 is equal to 1830, which is P2 over P1, and then our I can't remember the question, but it's 1.4 minus 1 over 1.4 is equal to T2 is equal to 665.4 K, and that's how we find T2. And then to find V2, we use this equation as well as V1 over V2 is parentheses R1 minus 1, and then that's how we find our V2. For B, we will have to use the first law of thermo. We use P1 V1 minus P2 V2 over R1 over V1. So we do that 100 times 0.832 minus parentheses minus 1830 times 0.1043, and then this is how we find that. All right, so for process, that's for part B. For process 1 to 2, we to find the I believe it was a heat transfer. We do U2 minus U1 plus the process, the work. So we do 269.17 plus 205 is equal to U2, and so that's how we find that. For process 2 to 3, to find the heat transfer. Oh, that's the heat transfer. Yeah, we do CV, and then the temperature, and then U3 minus U2. So that'd be 1275.11 minus 475.17, and that's the heat. Same thing here. The refrigeration cycle, since it's a negative, that's why it's a refrigeration cycle and not a power cycle. If it was positive, it would be a power cycle, but since it's negative, it's a refrigeration cycle. And then we use this equation to find the coefficient, which is 1.91. For PV diagram, this is what we have. Constant pressures P1, T1, P2, T2, P3, T3, and then since it's a constant pressure, the MPa stays the same. The T1 is 540, T2 is 1,300, and T3 is 1,300. So for Q1 minus 2, MCP T2 minus T1. So we plug that in from the given, and that's how we get that. where is it? P, yeah, but in order to get that, the rest, we do P1 V1 over T1, P2 V2 over T2, and that's how we get the 1,300. P2 V2 over P2 equals P3 V3, and that's how we find the V3, and that's what we use to plug in here, because we need the MRT is ln of V3 over V2, and then since we do that, that's how we get 1011.37 kilojoules once you calculate that. And then yeah, you do the you plug in that formula, and that's how you get this. For question 9, this is the PV diagram and the TV diagram. I wasn't 100% sure on the TV diagram, but I know that this was the temperature at 520. This is state 1, state 2. Yeah, so since there's not a, how do I explain? Since there's not like a table, like a number exactly at 520, you do the number we have to do interpolation. So we have to figure that out first, and then we can use that number, the number that we get to plug that in. So yeah, so this is the given, and then yeah, H2 is equal to HF plus the percentage of HG minus HF, and then we plug that in, we get that, and then we do Q minus W H1 to find the heat transfer, and then that's how we find that. For question 10, this is what we know. When it enters the turbine is 670, exits the turbine is 600. The mass flow rate is 0.02. The heat leaves the turbine at 0.5. The separate stream enters, this is state 1, state 2, state 3. The mass flow rate of the air is 0.018. Water stream heat exchange is 30. And so I guess this is all given. This is what we know. Yeah, so we do the here we have T2 is equal to T1 parentheses P2 over V1 R1 over R. Yeah, for state 1, so then we just plug that in. T2 is equal to 350.3. Okay, so then we use this formula to figure that out, and this is how you get that. And here is my pledge.